Hi everybody, I'm Professor Rad, and today we're going to talk about how you find a minimum sample size. So this is a situation where you want to get a confidence interval with a certain level of confidence and a certain margin of error. And so if you want to ensure that, you have to figure out, well, how many people do I need to survey to guarantee that level of confidence with that margin of error? So we're only going to look at this for z-score problems. We're not going to look at it for t-scores because the process there's a little bit more complicated. So here's our formula. So your sample size n is going to be z sigma over e, and then you square it. This is really the same as the margin of error formula rearranged. So it's similar to a formula we've been using, but we've just moved some of the variables around. Now, because we want this to be a minimum, you're always going to round up to the next whole number. This is really important. That's because, like, if you need to survey at least 15.2 people, if you only survey 15 people, that's not enough because you need to get at least 15.2. But you can't, interview 0.2 of a person. So you would round that up to 16 people. So let's go ahead and work through a couple of examples of using this formula. It says a population of weights is known to be approximately normal with a standard deviation of 1.02 grams. Suppose I want to make a 99.5% confidence interval with a margin of error of 0.5 grams. How big of a sample do I need to have to ensure this? So I'm highlighting the numbers they're giving me as well as some key words. So this how big of a sample is telling me I'm looking for a minimum sample size. I'm looking for n. The rest of this I'm just going to jot on the side. We've got a 99.5% confidence level. Sigma is 1.02 grams. And my margin of error, which is E, is going to be half a gram. We're trying to find n. So my formula for n is z sigma over e squared. I have e, I have sigma, but I don't have z. So we have to find that first. So this is really like a two-step problem. I can't plug in right away. So first, I need to get z. And I do that by using my confidence level. So our level of confidence is 99.5%. So I'm going to go to my table, and at 99.5%, I'm going to look for my z-score, so 2.807. So z is 2.807. Cool. Now I can plug into my formula. So n is going to be 2.807. So that's z times sigma, which is 1.02. Divide that by e, which is 0.5. And then this entire thing, so we need big parentheses here. They go over the entire thing, not just the top. Okay, important. We're going to square. So here's how I'm going to type that into my calculator. I start out with a parentheses, and then I'm going to do 2.807 times 1.02 divided by, so I haven't put in any more parentheses, 0.5. Now I put in the closing parentheses, and then I can use my x squared button. So I'll hit enter. And I get 32.790 whatever, 28264. You don't have to write that whole number out. I just like to so I know what my work was when I was going to round. So we're going to round this up to the next whole number. So the next whole number after 32 is 33. So this is a population of weights, so I need 33 weights. So you'll notice I didn't even pay attention to the fact that this was a 7. I just know I round up after I find this. So the 2 would round up to a 3. All right, so here's another example for you to try. I'm going to ask you to pause the video here and see if you can figure this one out. And then you can unpause and I will have my work here so you can compare. All right, let's see how you did. So in this example, it says that Kellen wants to conduct a study to see how much sleep college students are getting. They would like to create a 90% confidence interval and are using an historical standard deviation of 83 minutes. If they'd like a margin of error of 9 minutes, what is the minimum sample size Kellen needs to examine? So I put my summary over here on the left. So we have a 90% interval. Our sigma is 83 minutes and E is 9 minutes. So that's our margin of error. We have to figure out N, our minimum sample size. So I used my table to get my z-score. So for 90%, my z-score was 1.645. And then I put that into my formula, which I put into my calculator. And at the end of it, I got this very large number. And then, oh golly, I messed up my rounding. Look at me making mistakes too. So 230 is going to round up to the next person. So it should be 231 people. All right, so I hope you found this video helpful. In the next video, we're going to start talking about another type of inferential statistics called hypothesis tests. So I'm looking forward to seeing you then. In the meantime, have an excellent day. Bye, everybody.